Cool, we are live. Yeah, so it's very late at night, and I'm just going to be live streaming for about an hour or so. I'm simply going to be continuing my learning in public, which is App Router. Yesterday, we were somewhere around here regarding some experimentation that we did. Let's just start it. We were doing certain things around the image and all of that, but let's see where we are right now. Yeah, we were doing certain things around image. I can just remove the image part, no longer needed. I will just do this, bring it back to home page, and this should do it. I've installed the Chrome browser because it remind me later. I wanted to show you guys certain things, which is to say, if you inspect here and make it big, here you will find there's something called performance insights, and this is a very useful tool because what this do or what this does is that if I just you know bring it back, remove it, uh start it. Yesterday I already built certain things. Oh, okay, so let's just build it again. While this is building, we left it somewhere here only. I should pop out the chat and I should be able to do this, should be able to do this, should be able to do this. Fair enough. Yeah, maybe I can just do this. Yeah, this works. Anyways, so if you haven't watched yesterday's video, you can just go back at the very end and you will find that I optimized certain things using the inbuilt feature of image tag. And one thing that I did do is install something called Sharp, basically pnpm add Sharp. It's a package which is recommended by the Next.js in the documentation itself. It was showing in this here, right here. Okay, so I'll just start it now. We'll go back and reload it. And where is the package JSON? Here, right here. Okay, this is it. This is this Sharp package that I just installed because Next.js said to install it as a standalone image optimization package. It showed it in right here. Okay, this was after I stopped streaming. Anyways, so this performance insight is available in Chrome browser, and what it does is if I just pull it out, you'll find uh, you will find, can I do something like, no, we can't do that. Anyways, you'll find something. Yeah, this works. Now if I go with this, go to this performance insight. Cool. So here's the thing, if I don't have this width and all of this, the quality or the priority as true, should I show that first? Yeah, let's show you that first. Here I can say somewhere around what, where is the image in this public? If I just go and reveal in Explorer, Explorer. Explorer. Wow, I am not even able to pronounce it. This is somewhere around properties, details, 59953664. Okay, so let's make it 5995 first and 3664. By the way, the image is taken from pixels and I gave the credit yesterday in my video itself. Just making it out here, you know. Okay, so this is not optimized image, it's just an image within src alt complete width, complete height, complete quality, and then I will simply build it. Cool. Yeah, fair enough. It built. Now let's start it. Go back, restart it. Now it is coming. See, it is a very big image. Now if I go and inspect, go to this lighthouse, uh, and simply analyze it for this mobile performance. Okay, it is doing what it has to do. This is related to something called performance optimization. It is one of the things that I am working right now in my company, and basically what I am working right now. Let's just put it that way. It's kind of like a like it's not. I won't say it's a good experience, but it's a very great learning experience because it's a lot of trial and error. Even though you know what has to be done, sometimes it just does not work for no reason. And there's a lot of reason. By the way, I know the reason, but it has nothing to do with the technology itself. Sometimes it's just the physics comes in because your laptop or your so-called desktop is able to produce something around 60 watt per hour or something, that much of a power. And in terms of like heat dissipation, whereas that much amount of power can burn your hand if your mobile device starts dissipating heat at that rate. And in electronics terms, power equals some like heat. You can just imagine it like so. And yeah, your battery is also not good in mobile, so basically you are pretty much destroyed by your mobile device's performance is not equivalent to whatever performance it shows here, right? It will be much worse. And the reason being that it is limited by the battery, it is limited by the processor, it is limited by the network speed, which is not equivalent to whatever the throttling you do here. But still it gives you some sort of like estimation key how like what is the trend, and I'll just show you what I mean by that. Anyways, as you can see, this is the score, this is the problem LCP, and everything else is fine. So in order to improve this all we have to do is fix this LCP. And this is the image. Well, it says the above the fold image that I lazily loaded rendered later in the page cycle. What it says is that this image by default is not being fetched as a priority to be high. So if I go to the network tab and if I click on this image, you will see if I click here, somewhere here there's a thing called priority. It has to be here. By the way, the content type, as you can see, is already WebP, even though the image, if you see here, is JPEG. So the sharp is converting the thing completely fine. But what I want is this. Where is this something called priority, if I'm correct, it is here only, or maybe I'm wrong, but it comes somewhere. Yeah, AVIF is greater than WebP. That's true, but I have just let the Next.js decide what to serve at this point. AVIF, by the way, is a latest format in even better and latest than WebP. So yeah, if the browser supports it, it can be supplied directly to that. But I think Next.js is deciding that it has to be WebP. One thing that you can do is that in this Next.js configuration file, this is something that was present even in the previous architecture itself. You can pass certain things like images, and then you can pass the domain. If you are using some sort of like a CDN, then you can pass a domain. You can pass a loader as well, like what loader do you want, and then you can also pass the format, and there you can define image slash avif comma image slash webp. And if you define it in that order, what the Next.js will try to do is it will try to convert it first into this avif if the browser supports it. If it does not, it will go to the webp, and if that also doesn't happen, then it will go to whatever the format you have given by default. But most likely all the modern browsers will support at least webp. Okay, that's a safe thing. Hmm. So if I go to this performance insight now, see, there are three modes. Let's start with this. And here's what I wanted to show you guys. Like, this is something that you should be doing every time you are building a front end. Otherwise, you can actually go in a very bad direction in terms of performance. Start with this option called slow 3G, and then 6x slowdown of the CPU, and then also disable the cache. Okay, slow 3G, 6x slowdown, and disable the cache. Now measure the performance load. I cannot speak certain words at night for some reason. But anyways, you can see what is happening. The speed is slow 3G while measuring the performance, and the CPU is also throttled by approximately 6x. 6 times is slower than whatever the CPU is. So it's trying to replicate certain scenario what could happen in your mobile. And then also assume that your mobile will be like a little bit worse than that. Okay, but most likely you can't do much, except you can, what you can do is apart from all of this techniques, the best way is to connect this real physical device. Buy any physical device or ask your company to provide you any physical device which is the bare budget phone, right? Because that's the phone that will be used by the majority of your populace, right? So if you are in India, like I am, what you want to do is get any phone, maybe 2 years old phone, which is less than 10,000 rupees, right? And then try to test it on whatever you are doing, test on that. You can see that that will be the real world performance for most part of your customers. Unless you have a customer base which is tech savvy and rich enough to afford everything new, then yeah. But even then, you will not be getting the mobile, I mean, laptop performance anyways. So this is necessary. Cool. See, this is the LCP, 42 seconds, 42, yeah, 43 seconds around. Okay. And if you see the network tab, there's also a problem. See this image? This is the image, which is, should I make it big? Yeah, this is fine. So see, this is the HTML, right? So first the HTML is loading. As soon as the HTML completely loads, then the CSS is loading, then the JS is loading. Okay, Next.js and then RJS, whatever the RJS is. And once this is also loaded, right, then the image is being loaded. This is the image, green. Okay, and then the favicon is being loaded and the rest of JS. So this is how it is. Thing is, the LCP is done and dusted once the entire image is loaded, and this whole thing And the reason why it is doing is because largest contentful paint is actually basically decided on if in your viewport, technically speaking, if you have a large image like we had right now, the LCP will be once that entire viewport is loaded. Whatever the largest contentful paint is in that thing, in our case it's an image, once that is loaded, it will take that time. So in our scenario, the LCP is very bad. If we are on slow 3G, 6x slowdown. Now look what will happen if I just move this like fast 3G and do the performance testing again. It is right now 43 seconds approximately. And second thing that you had to note is that the HTML is loading first, then the CSS and JS, and then the HTML, then the image is loading. So it's not, so there's not like the image is being loaded lazily. Okay, that's what it means. Let's let it complete. And today I'll just be doing this performance thing, just showcasing it, and then we'll be like going off. It's too late at a night. Just wanted to come back because I forgot to do this yesterday because I did not had the Google Chrome installed. Okay, fair enough. And now first thing that you have to see is Mhm. Okay, so this is what you have to see first. The HTML is again loading, then the CSS and whatever the JS is being loaded, and it is kind of like a waterfall model. And then here the image starts. This light screen or light green, or as you can see even here, the light green is basically the server response time or whatever. And then this is the rendering time of this page. So, I mean, you got the information, but the browser is rendering. Okay, the same is true for here as well. Mm. Mm. Okay, the same is true here as well. So you got the information, and now from here to here the browser is rendering. Now the LCP at this point is somewhere around 1200 milliseconds. Yeah, here as you can see the priority is also low. Okay, it is not coming from cache and it is not coming from the service worker either. So caching is one of the techniques that you can actually do, but we have disabled the caching, so that's why it is not happening. Otherwise it will be picked up from the cache. And priority is low, which will solve this waterfall model for this image. So the moment we set the priority as high, what it tells the browser is that this particular image, now this particular image, you fetch it as you make the fetch priority property of this particular image to be like high. So you can look at from this perspective. There's a image fetch priority. Okay, here you will find HTML element. It says this is experimental technology, blah blah blah. You can go and search this browser compatibility, and come on, see, the only thing it is that it shows ki Firefox is not supporting it, right? Firefox for Android is not supporting and Safari is not supporting. But I think the latest one kind of like started supporting it. But this is exactly what we are trying to do, fetch property. It is experimental, but most likely Firefox will be supporting it. Let's see. Firefox fetch priority. This is also here, web dev. No thanks. Yeah, Firefox is not supported. Safari is in preview mode. Right. Okay. So in our case, Firefox is not being supported, but I think they are building some sort of things. But anyways, you can do it in Next.js, and the Next.js will take care of it somehow. For the Chrome, it will, I think, default to the real way, and in Firefox, maybe it will do it, maybe it will not do it. I am not sure. So yeah, but if you look at this point, this is around 12 seconds. Okay, so from 42 seconds of LCP, we are back to around 12 seconds, or maybe, right, yeah, around 12 seconds, 12.27 seconds. And inside you will have DLs. Let's see, where is the LCP? I think it stopped talking about the LCP altogether. Yeah, it is not looking into the LCP. Don't know why. But LCP will be around 12 seconds now rather than 42 seconds, because this is the else largest contentful paint object. So it finished here, so it will be somewhere around here. Now what I'll do is I will slow down, like speed up the CPU again and measure the load one more time. Right, we are now in the like fast 3G, but and also a little bit faster CPU. And mind you, there is no optimization of the image till this point. Image is still the unoptimized image that we are serving, and whatever the optimization is happening is because of the inbuilt Next.js thing using the sharp tool. Okay, now you will see the LCP is now showing as 34.27 seconds, somewhere around here. And I think this is like, should be right here now. Why it is happening here? There's nothing here in the first place. I don't think this is, what is this? The image just completed here itself. Image completes here at best here. So let's assume it to be like 12.24 seconds, because there's nothing that is happening here in the first place. The main thread is blocked. What is this then? Navigation event, DSL, DCL, DOM content loaded. Okay, DOM content is being loaded, so I understand. Even though the image is like done here, the DOM content is still being loaded. Okay, but the image itself being loaded is like now 20 seconds or something less, but the DOM content is being loaded still. And there's some sort of like a task that is going on. And if I do it like a no throttling in terms of CPU, measure it again, let's see what happens now. Okay, so this is the problematic part. but the image loading is now again like somewhere around the same. If I just remove this no throttling part, everything is like no throttle. Why is this happening? This is new. Like, what DOM content is being loaded? If I just measure the page load again, everything is like fast now. When everything becomes fast, as you can see, the LCP also reduces from 32 seconds or something directly to 13 seconds. But this is still not optimized in a way that it can be done. And if I just make it like so, this is where the image is coming now. And here the main thread is being run. This is like what? Where everything starts. This is the run task. Then certain things are happening here. Finally, the favicon. But there is something called somewhere around here things are stopping. Okay, now if I just close this around 13 seconds or something, now what we'll do is first we'll add the priority, then we will add whatever the exact image size that we need in terms of width and height. We will let the quality be as it is. We don't care about that. Basically, in by default it's 75, but you can have it like set to 100 if you want a crisp image. Then we will build the entire thing once more. You can go back here while this builds up. Okay, it built, and we can just reload the page by starting the thing first. Then simply reload the page, inspect it again, go to our performance insights. Again, I will say no throttle, or I can do, let's go with the no throttle first. Here we will find that when nothing is being throttled at all, everything is like a full speed, we will see that DOM content loaded also happened within 0.1 second, and image and everything became like green. But more importantly, you have to look something like this. The waterfall model is what's more important. So right here in this network tab, you see that this is where the HTML is loaded, but then the task in the main thread starts running as well. This is where the image, I mean the CSS is coming up. Also, this is exactly where the image is now being fetched, rather than the before the JS is being fetched, because this is now as a priority, it is being fetched in parallel to CSS. Now we just told the browser to fetch it as a priority element in our DOM, and then the browser will decide when to fetch it. You cannot manage it like to fetch it with this itself, like I mean with this itself, or with something here or something here. Like this is something that the browser will do. But as you can see, this is where the LCP ends. This might be our the main thread, after which everything becomes like interactable. So LCP ends right here. Okay, and DOM content loaded is also something that completes right here. But if I just reduce this network speed to slow 3G, I won't be reducing anything regarding the CPU. Simply measure it again, right? That part of this parallel loading, whenever the browser decides, will not change. What will change is that the render portion of that entire LCP. So LCP is divided into 4 segments: TTFB, time to first byte, which is a server driven scenario. So as a front end developer, you cannot do anything except maybe serve the pages, which is the static pages from the CDN itself. Then you have load time, then you have there's a load delay, and then you have to the render delay or render time or something. Render time is basically when once all your information after the first 3 steps is with your browser, but still it takes some time to render the entire thing. Okay, why this, like, I need the LCP. There was no LCP shown. Show me the LCP now. Also, just the network speed being slow, you can see that this entire thing was quite bad. So LCP became 14 seconds, right? On the slow 3G. Most likely your so-called person or so-called user will be sitting not on just slow 3G, but also on 6x throttle of the CPU in their mobile. Then you measure it again and you'll find something the real performance most likely. The only silver lining is that you can hope for most part your users have better mobiles, and the median, and when I say the median, I mean the 75 percentile of the uh, user base is at the green LCP range rather than whatever is the range that is being shown right here, the 14%, right? See, 14 seconds, it's a very bad thing. The reason why it's bad thing is because most users do not wait for more than 3 seconds, and that means 53% or something users leave after 3 seconds, and your highest level of, like, your page is still being loaded till 14 seconds. Okay, but what will happen if I just do it like a fast 3G? Assume that your users are on some better plane or better, or your user demographics is somewhat better, right? And even then, so they have like better network speed, at least 5G, 4G, whatever. Even though as the user base increases, these network speed keeps on decreasing, which is bad. But that's how it is. It's not like these speed go up. They're basically in a very simple manner. This is how the uh, mobile network speed behaves, to be quite honest. So you can think of this as like a y-axis, and this is like a x-axis. This x-axis will be your like time, and this y-axis can be your users. Okay, now in the beginning, something like, okay, so as the time increases, I mean, this can be speed. Now this is basically users and this is speed, right? And you can say in the beginning, when the users are like less, say any new network spectrum is released, say 5G, when the users are less, right, it will be very good speed. But as the user base increases, it starts decreasing, right? And somewhere it attains somewhat like a median scenario as the user base increases with time. And you can save users with time. Okay, speed mobile internet. And this is true for any country. It does not matter which country you belong to. That's why people who are in India, you guys can actually relate to that. It is just based on experience, to be honest. And that is to say, when the Geo released itself, in the beginning it was very great, very great, to be honest, like huge speed speed to be right speeds were given. But as the user base expanded, the speed got divided and speed decreased and became even slower, or sometimes somewhere around mid of 3G. The same will happen with 5G eventually, as the user base increases. Okay, right now it's very good, but eventually it will decrease. Cool. And this is the mobile network. Thing is, still with the fast 3G and 6x slowdown, you will find that at least your large LCP is 3.95 seconds. It should be some, if you, I'm not talking about the don't look at the absolute number. You should be looking at the trend from 13 to 3. So it's that trend that we are talking about. Key, yes, with the increase in network speed, at least your LCP will decrease. And if you have better CPU as well, and then do the entire performance load again on the fast 3G network itself, maybe it will decrease a little bit less, more, right? So you will find, yeah, so that didn't make much difference. So you can say 3.99, 4.04 is the same thing. It didn't make much of a difference. So CPU is not making much of a difference. But if you have a no throttling, everything is flying high in the mobile itself. Now, if we have to measure in this mobile device as well, this is also a diagnostic tool, again, not an absolute number, because the percentile value is what the Google cares about. It does not care about absolutes. That means if you have 100 users and 75% and 75 of those users have better performance in the green zone, let's say, as the Google defines it, then you pass the test. That's about it. I'll show you while this is happening. Let's let this happens, and then I'll just show you what I mean. There's this site called ping.gg, right, which is something that I think it was from Theo's startup or something, right? It's a website. We will do one analysis of that site and just show you what I mean by that statement, that 75 percentile statement. So you can see it's still in the mobile, it will be 47. This is the problem, right? Properly size image. See, this is too big. Now in mobile, it is saying there's also some property called sizes. I won't go too much into it, but that's how you can actually define multiple sizes. Okay, you can define certain things, but if I just reduce this to say 480 by